Okay, in number 7, how many ways are there to pick 4 blue marbles from bag C so that at least one is blue? Well, if at least one is blue, I could have 1 blue or 2 blue. So 1 blue would be, of the 2 blue marbles, choose 1, and of the 6 other marbles, choose 3, because I need to get 4 marbles total, right? So I got to pick 1 blue and 3 of the others. 2 blue, we already saw, is going to be 6 choose 2 times 1. And since I can have 1 blue or 2 blue, but not both at the same time, there's no overlap there, I'm just going to add those 2 cases up. I could also do this another way. The total number of ways of picking marbles, remember, is going to be 8 marbles, choose 4, but I don't want all of the ways. I got to have at least 1 blue, so I'm going to take out the ones that have no blue marbles. All the ways minus ways with no blue, because I want at least 1 blue. So it's 8 choose 4 minus 6 choose 4. Okay, so 2 ways to do that problem. Sometimes this way is easier, because if I had a lot of cases here, suppose there were 8 blue marbles in the bag, I wouldn't want to do 1 blue or 2 blue or 3 blue or 4 blue. I wouldn't want to do all of that. So this way, when you take all the ways minus the ways you don't want, is sometimes easier. And this is called using the complement. Okay, number 8. In a lottery game, 4 marbles are picked from bag C, and a person wins if they have matched all 4 numbers in order. That's important now. How many ways are there to pick 4 marbles from bag C in order? If it's order, then we're really talking about a permutations problem. There are 8 marbles in bag C, so if we pick the first one, then we've got 7 for the second one, and 6 for the third one, and 5 for the fourth one. This is 8 times 7 times 6 times 5. You could also write this as 8 things permute 4 of them. And that's how many ways to pick 4 of the marbles in order. Number 9. In the lottery game described in problem 3, a person wins second prize by picking 3 of the numbers in order. How many possible ways are there for winning a second prize? 3 of the numbers in order. So let's suppose we had 10, 14, 8, and 13 are the numbers. So a person would win second prize if they picked 10, 14, and 8, or if they picked 14, 8, and 13. So there's 2 ways to win second prize with that set of numbers. Okay, so there's 8 arrange or 8 permute 4 sets of numbers, and for each one of those there's 2 ways to win second prize. So this is going to be 8 permute 4 things, all the ways to pick the 4 marbles, times 2, because for each one of those there's 2 ways to win second prize. Okay, how many ways are there of picking 1 marble from each bag? If I'm going to pick 1 marble from each bag, that means I'm going to pick 1 from A, 1 from B, and 1 from C. That's just fundamental accounting principle. I've got 3 separate pools. So it's 3 times 4 times 8. You could also write it this way: 3 choose 1 times 4 choose 1 times 8 choose 1. I'm picking 1 marble out of each bag. How many ways are there to pick 1 marble from each bag so that there are no orange marbles? Well, if there's no orange marbles, I just got to eliminate those. So it's going to be 2 times 3 times 7, or 2 choose 1, 2 non-orange marbles, pick 1 of them, times, in bag B, 3 non-orange marbles, pick 1 of them. In bag C, there's 7 non-orange marbles, pick 1 of them. Still fundamental accounting principle. How many ways are there to pick 1 marble from each bag so that there is at least 1 orange? Oh, so this is a place where the complement is going to be handy. I want all the ways minus no oranges, because I want at least 1. So it's 3 times 4 times 8 minus 2 times 3 times 7. And I'll finish the last few problems, because there are some bonus ones on this video. I'll finish the last few problems on the next video.